All right, we're going to start with parts 11-3 this week. There's 4 days, no school on Friday for us, so there's not going to be a lesson on Friday. We're doing rational square roots. Square roots are basically, if we have a symbol like this is called our radical sign, and then this is called the radicand. Radicand's the number inside. Rational square roots means all these answers are going to come out to be a rational number. A rational number is one that either repeats or terminates, a number that stops. Irrational is one that goes on forever and ever without repeating or stopping, things like pi, or for instance, if you put square root of 2 in your calculator, it's at 1.4, and it keeps going on and on and on and never stops. Whereas if we come over and look at the square root of 16, what number times itself is 16? 4. Later, and this is more of a later thing, if we have something like this and it says what number equals the square root of 16, then we're going to get them, no, it's the other way around. If it's like this, x squared is 16, we could get 4, or we could also get -4, because -4 squared is 16. But for today, if it just has the square root, then it's going to be, whoops, it's just going to be the positive. But if it has this, then we'll say, okay, they want the square root of 4, but then now they want the negative. You might also see it this way. This means plus or minus, so positive or negative. What's the square root of 16? 4, so it could be positive or -4. That's how you would write it. We can also do these as fractions. Sometimes you'll see a problem like this, where you could try and figure out the fraction, or you could break it into 2 separate parts, 2 separate radicals. So square root of 25 is 5, square root of 36 is 6. Much easier than trying to figure out, okay, what fraction times itself? Break it into the individual parts. Likewise, if they give us a problem like this, and you don't have your calculator, we can break it down into smaller things to make it an easier problem. Now, let's do a smaller one first, and then you'll see it. 16 we know is 4, but let's say you weren't sure of it, and you broke it down. What's the square root of 4? 2, and the square root of 4 is 2. That equals 4. So we got the same answer, but doing it a different way. So we want to try and look at this and figure out, are there perfect squares we could break it into that would make it an easier problem? 20 is not a perfect square, but think, what's that right there? Okay, 4 times what? 4 times what is 100? Are those both perfect squares? And then we'll do it where we break it down a little bit different too. So that's 2, that's 10. Or is that, were you telling me the answer was 20? Oh, I didn't want the answer. I wanted how to get there. So we could have done it a different way as well. Could have been 25 times, what, 16? 5, 4. So if you don't know the exact one, for instance, let's do the harder one. 2,304, and you're not going to have your calculator, but can we break it down? So let's start with 4. But this is where we're going to need to do some division. Not 4 there, 4 there. So 4 will go in 7 times, 28, 24. What do we think might go into there? I got the cheating method over here, Michael. Let's try 9. So 9 times 7 is 53. No, that's 63. 9 times 6, there we go. 54. That doesn't work. They say it works. My math wrong. That's 6. Okay. That works. Okay, so we get 36, 9 goes in there 4 times. Now, what are we left with? 64 is that a square root? So we could get 2, 3 times 8, 2 times 3 times 8 is 48. So if you don't have a calculator, we can break it down by, start small. I mean, go that way, that's one way to do it. So you know your squares are 4, 6, 9, 16, 25, 36. Find one of those that could divide into it, 49, 64, so on and so forth. Okay, last part. If there is one. No, we are good. All right, on page 519. One to 31 odd. Most more problems, but most of these you're gonna whisk through real fast. So 1 to 31 odd, 519.